Hello everybody, this is T Cubed, and today I'm going to be showing you how to solve the Rubik's Cube using the CFOP method. Okay, so what CFOP is an advanced method of solving a Rubik's Cube used by some of the best speed cubers, so it's going to allow you to get very fast. This method is used by Felix Zemdegs, Mats Valk, Patrick Ponce, all of the very good speed cubers. So it involves 4 steps. It's an acronym which has 4 steps: cross, F2L, OLL, and PLL, CFOP. So cross is solving a pattern on the white side which looks like this, which looks like a cross shape, like that. So you're just going to solve all the white edges first, which is called solving the cross. The next step is F2L, which involves solving the first 2 layers simultaneously, rather than separately, on the beginner's method. On the beginner's method, you would first solve the corners and then the edges. With F2L, you solve them both simultaneously, which is going to allow you to get it done much more efficiently. The next step is OLL, which involves using an algorithm to solve the orientation of the last layer, otherwise known as getting the entire top one color. Next up is PLL, which stands for permutation of the last layer, and that just is a fancy way of saying do an algorithm and finish the cube. So as you can see, it involves much less moves than the beginner's method. Once you get good, you'll be able to do it in about 60 moves, eventually even less. So the first step is cross, which you should already know how to do if you learned using a beginner's method, such as Dan Brown's method, which all start off with a cross. Next up is F2L, and you have to understand a few concepts for F2L before you go learning it. So F2L stands for first 2 layers, and you solve the corners and edges simultaneously. I already said that, and you use these pairs to do that. A pair of a corner and an edge that need to go into the same slot, and you can insert them using an algorithm like this: U, R, U prime, R prime. Or you might have to do U prime, L prime, U, L to insert it from the left. Now, you're not always going to have these pairs pre-made. So one of the cases that you will have is where the red, white, and green pair, red, white, green, and now the corresponding edge here is going to be red and green. So here it is, and if you look at the color on the top, they're the same: green, green. Now the way you're going to do this, the way you're going to make this into a pair, is you're going to hide the corner, which means you're going to put it into the bottom layer. Make sure the slot you're moving up into the top layer is an unsolved slot, so that when you twist the top layer, you're not messing up something you already did. And then move the edge around by twisting the top layer so that it's directly next to the corner, and when you bring it back up, they will be paired up, and you can quickly insert them. So another case is when we're going to be doing the white, blue, and orange. White, blue, orange. And now here's the corresponding edge, but if you notice, white is on top, which is the color from the bottom. So if the color from the bottom is on top of the corner, then you're going to do something a little different. You're going to hide the edge, and then twist the corner, twist this top layer so that the corner ends up on top of the edge, then unhide the edge. So now it's a pair ready to be inserted. The last case is when the colors on top are different, but the color facing up on the corner is not white. So the colors are different. So in this one, you're also going to be hiding the corner, but instead of moving the edge next to the corner, you're going to move it directly across from the corner, so that when you move it back up, this is considered an F2L pair right here, when both of them are different, and this one is directly across, because you can insert it using 3 moves like this. By doing this, so L prime, U prime, L, or R, U, R prime, which is a very common algorithm. Now, This is not very intuitive, so it's a little hard to understand, but you can do an insert like this. So the next step is OLL, which stands for orientation of the last layer. Now there are 57 OLL cases that you have to learn and memorize, and I have done that, but you don't have to yet. You can learn what's called to-look OLL, which is only 9 algorithms, which is much more manageable to learn. And it will be much faster and more recognizable than the current last layer method of the beginner's method. So I'm just going to give you an example of a last layer case, of an OLL case. So you're going to do 2 different algorithms when you do this. You're not going to be able to solve it in one algorithm. So the first thing you want to do is get a cross on top. So there are 3 cases. You're either going to have a dot like this, an L like this, a line like this, or a cross like this one. So when you have the dot, this algorithm is a little hard, but it's actually 10 OLLs. So I messed that up. I thought it was 9, but it is 10. So you're going to do this algorithm, which is not too hard, but it is a little bit difficult. R, U2, R prime, sledgehammer, which is R prime, F, R, F prime, U2, and then sledgehammer. And that will solve the cross. So if you have an L, shape, then you're going to do a wide F, R, U, R prime, U prime, and then wide F prime, and that will get you the cross. And if you have a line, then you're going to do this algorithm. F, R, U, R prime, U prime, F prime. And you're going to end up with a cross. Now there are 7 different cases once you have the cross. The first one, I'm just going to do this now because I already have it, is called the Bowtie Case, where you have 2 opposite corners solved, 2 opposite corners not solved. So when you have this case, you're going to hold the cube like this, and you're going to do F prime, wide R, U, R prime, U prime, wide R prime, F, R, and that will solve OLL. So the next case is called soon, which kind of looks like a fish. If you hold it like this, kind of looks like a fish. So when you have this case, you're going to hold the cube like this, and you're going to do a very easy algorithm that can be executed in less than a second with some practice. R, U, R prime, U, R, U2, R prime. Very simple. So the next case is anti-soon, which looks exactly the same at first glance, but it's actually these corners are rotated the opposite way. So when you have this, you're going to hold the cube like this and do the inverse of soon, which is R, U2, R prime, U prime, R, U prime, R prime. So the next algorithm, the next case I'm going to show you, looks like this. This is the Headlight Case, where you have 2 unsolved corners facing towards you. And the algorithm for this is R2, D, R prime, U2, R, D prime, R prime, U2, R prime. So the next case looks like this, which is very similar to the Headlights case, but the 2 unsolved corners are facing outwards rather than towards you. And you're going to hold the cube like this for this case. And you're going to do a wide R, U, R prime, U prime, wide R prime, F, R, F prime. It's very similar to the Bowtie Case. Try not to get those 2 confused. So there's only 2 more. The next one is where none of them are oriented, and you have 2 unsolved corners facing you, 2 facing away, and you're going to use this algorithm. F, R, U, R prime, U prime, R, U, R prime, U prime, R, U, R prime, U prime, F prime. So, and the final case looks like this. I'm just going to twist the corners. Okay, so the final case looks like this. It's very similar to the case that we just had, and this is called pi, because it kind of looks like pi if you hold it like this, the symbol for pi. And to do this case, you're going to hold the cube like this, where two of the headlights are facing out off to the left, and one is facing in front, one is facing the back, and you're going to do a wide F, R, U, R prime, U prime, F prime, F, R, U, R prime, U prime, F prime. So now you're going to do PLL. Now, to a PLL has only 6 algorithms. So the first one looks like this, where, so the first thing you want to do is solve the corners. So, find a headlight, which, during PLL, a headlight is 2 corner pieces that have the same color on one side. And you're going to look for this, and once you find one, you're going to move it to the back, so that you can't see it. And then you're going to do this algorithm. R prime, F, R prime, B2, R, F prime, R prime, B2, R2. And that will solve all the corners. Now, if you do not have any headlights, which is completely possible, here, 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 and here, so there's no headlights here, you're going to use this algorithm. F, R, U prime, R prime, U prime, R, U, R prime, F prime, R, U, R prime, U prime, sledgehammer, R, F prime. Okay, so next you're going to solve the edges, which there's 4 different cases for. The first one is this one, which is called U permutation, where there's a completely solid side, and these 3 edges need to be cycled clockwise. So for this one, you're going to do R2, U, R, U, R prime, U prime, R prime, U prime, R prime, U, R prime. So that's a completely 2-gen algorithm, which means it only uses 2 different sides turning. So the next one is the same case, except the pieces have to be cycled counterclockwise. And to do this case, you're going to do R, U prime, R, U, R, U, R, U prime, R prime, U prime, R2. So then the next case looks like this, where you have all the headlights, and these 2 edges need to be switched across, and these 2 edges need to be switched across. Now this is a very simple, very quick algorithm with some practice, and this algorithm goes M2, U, U, M2, U2, M2, U, M2. So that can eventually be executed extremely fast. So the next algorithm is called Z-Perm, or Z-Permutation. So it looks like this, where there's 2 adjacent swaps and 2 adjacent swaps in the back. So you're going to get it so that one of the swaps goes from right to front, the other swap goes from back to left, and then you're going to do a very similar algorithm to the last one, and it goes M2, U, M2, U, M, just one M, U2, M2, U2, M, U2. And that's it. That's it for CFOP. And I hope you get faster with this method. I hope this helped you. Don't forget to subscribe to the channel, leave a like, comment, and if you have any questions, leave them in the comments. So I think that pretty much covers it for CFOP. I'm just going to finish up the solve. It's hard to solve in front of the camera. Alright, so I average about 16 seconds with this method. I know that's not believable with what I just did, but I have my arms around a camera, so it's a little harder. But yeah, I'm just going to do one quick example solve, so you can get the hang of it. So, I see my cross pieces here, here, and there, so I'm just going to insert red and blue at the same time, like this. And then I'm going to insert orange. So now I'm going to use this as my first pair. I forgot to mention, a lot of times you'll have one piece of the pair in the top layer, one piece already in an unsolved slot. All you need to do is take it out like this, and then just deal with this case. So this case, I have a different color on top, so I'm just going to move them across from each other, and I'm going to insert them into that slot right there. So these two pieces are next, which they're a different color on top, so I'm going to hide the corner, and then I'm going to insert them into the slot. Now the next one is this case, so I'm going to separate them. Now I'm going to hide the edge since white is on top. Now I'm going to move this directly on top of it, and now insert the pair. So next up we have this case, so we got all three different cases. And next up we have the case where both on the top are the same color. So I'm just going to hide the corner, move that to the back, and make the pair. And now I'm going to do OLO, just like that, and PLO. And the cube is solved. So if you see that stuff fast, you'll be able to do it much faster. There are a lot of time ranges using this method. You can average anywhere from 7 seconds to like 30 seconds. So it just depends on how much you practice, how good you are, and how much you know, how much experience you have. So I hope you like this video. Bye.